Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABES Engineering College, Ghaziabad. In this video, we will cover the important topic decomposition. Now, decomposition refers to the division of a table or relation into multiple tables to produce consistency in the data. Actually, we are doing the normalization to reduce or remove the redundancy. If there is a redundancy exists in a table, then to remove or reduce the redundancy, we will decompose the table into two or more parts. So decomposition is the division of table or relation into multiple table to produce the consistency in the data. So there is two types of decomposition. First one is lossless decomposition and second is lossy decomposition. So now we will understand this concept lossless decomposition and lossy decomposition with an example. There is a relation R. Attributes are A, B, C. So here is the table of a relation R. A, B, and C. Now the tuples are 1, 2, 1, 1, 2, 3. There is 2, 2, 2, 3, 2. Now suppose we will decompose this relation R into two parts, R1, AB, and R2, BC. So in R1, there is two attribute A and B. Here is 1, 2, 2, 2, 3, 3. Now here R2, there is attribute B and C. So attributes are 2, 1, 2, 2, and 3, 2. Now as per father of DBMS, when we join these two tables, there should be some common attribute. So here B is the common attribute. Now what is join? We have already studied the natural join. Join is the cross product plus some condition. So natural join is cross product plus some equality condition of the common attribute. Now we will again rejoin this table, join these two tables R1 and R2 to get the same table. Now the cross product table is the attributes will be added A, B, B, and C. And the tuples will be multiplied. Here, 3 rows and here is 3 rows. So after cross product, 3 into 3, there will be 9 rows. 1, 2, 2, 1, 2, 2, 3, 2. Now here is 1, 2, 1, 2. Now, two, two, 2, 1, 2, 2, 3, 2. Now, 3, 3, 2, 1, 2, 2, 3, 2, 3, 3, 3. Now here is the plus some condition. Condition is of equality of the common attribute. So both are equal. So this row will be selected. Both are equal. So this will be selected. Both are not equal. We cannot select this row. Both are equal. We will select this. Now both are equal. We will select this. Both are not equal. Both are not equal. Both are not equal. Both are equal. So after natural join, the output table are A, B, C. We will get 1, 2, 1, 1, 2, 2, 2, 2, 1, 2, 2, 2, and 3, 3, 2. So here is total 5 tuples comes in the table R. Originally, in the original table, we have only 3 tuples. So there are these extra tuples here in this table. These extra tuples are produced after joining. So these extra rows or extra tuples are called extra or spurious tuples or spurious tuples. So this type of join, this type of decomposition in which extra tuples are produced are called lossy decomposition, or you can say not lossless decomposition. There is some issue in the decompositions, in the decomposition. That's why we will get some extra tuples or spurious tuples. So here is some data integrity issue after joining this table. So here the issue with the selection of common attribute. Now we will take a attribute as the common attribute. Now in the same example, we will decompose the table R into two parts, AB and R2 as AC. Now the table is AB. Tuples are 1, 2, 2, 2, and 3, 3. Now here in R2, there is AC. 1, 2, 3. Now here is 1, 2, 2. Now we will again join these two tables. So after joining, this is the cross product plus some condition of equality of common attribute. Now check the attributes will be added A, B, A, C, and the tuples will be multiplied. There is 3 into with 3, total 9 tuples. This is 1, 2, 1, 1, 2, 2, 3, 2. This is the cross product. 1, 1, 2, 2, 3, 2. Now here is 3, 3, 1, 1, 2, 10, 3. Now check equality of the common attribute 1, 1. Yes, this is equal. This row will be selected. 1, 2, not selected. 1, 3, not selected. 2, 1, not selected. 2, 2, yes, this row will be selected. 2, 3, not selected. 3, 1, not selected. 3, 2, 3, 3, that will be selected. Now, the after joining this table are that A, B, C, A, B, C. Now, here is 1, 2, 1, then 2, 2, 2, and 3, 3, 2. We will get the original table. So, this type of decomposition is called lossless decomposition. This type of decomposition in which no extra or spurious tuples are produced. So this type of decomposition, type of joint decomposition is called lossless decomposition. I hope you will understand the concept of lossy and lossless joint decomposition. Now, as per father of DBMS, there are two conditions for decomposition. When we decompose the table into two or more relation, so the decomposition should be lossless joint decomposition to achieve the consistency. And second, the decomposition should be dependency preserving decomposition. So later we will understand the concept of dependency preserving decomposition in the next video. Okay, what is this dependency preserving decomposition? So here we will understand the concept of lossless joint decomposition. So the conditions for lossless joint decomposition, there are three conditions, or the following condition must hold for lossless joint decomposition. That is, when we decompose R relation into R1 and R2, then the union of R1 union R2, that must be equals to R. This is the first condition. Union of the attributes of R1 and R2 must be equal. For example, we have decomposed the R relation is ABC. So R1 is AB and R2 is AC. The union is equals to R. Attributes, union of attributes are equals to R. Second condition, the intersection R1 intersection R2, that does not equals to phi, means that is not equals to empty. There must be some common attribute. As per father of DBMS, the we can decompose, we can join the tables on the basis of common attributes. So there should be some common attribute. So here the common attribute is A. R1 intersection R2 is equals to A. Now the third condition, it says the common attribute must be the candidate key of either R1 or relation R2 or both. So the common attribute must be the candidate key of R1, relation R1, or R2, or both. So for lossless joint decomposition, all these three conditions must be held by the lossless joint decomposition by the table. So I hope you will understand the concept of lossless joint decomposition. Further, we will learn some sample questions, some practice questions on this decomposition in the next video. These are the references. Thanks for watching this video.